Hello, this is Mr. Wynn, and this video is Transformations Part 1 over translations and reflections. So, transformations are simply changes something undergoes to get something new. The original or the before picture is called the pre-image. We usually just use regular letters when naming these points, such as point A and point B. The new or after picture is called the image. We usually use the original letter and add an apostrophe. We read that as prime, so we'll say A prime and B prime. This lets us know that A prime came from A, and you can also use more than one apostrophe. So we could also have A double prime, A triple prime, which would come from the previous point. So A triple prime comes from A double prime comes from A prime comes from A. Alright, anyways, there are four types of transformations in math that change the position of whatever we start with. It could be a shape, a figure, a point, a line, segment. Some even change the size or orientation. The four are translation, reflection, rotation, and dilation. That's the order I'll teach them to y'all in. And our job is to be able to identify each, describe the change in words and formulas known as motion rules, and even perform the transformations. So, first we have translations. That is known as the slide. Translations simply move or slide a picture up, down, left, or right without changing anything else. The shape, size, and orientation will remain the same. The pre-image and the image are still congruent. That means they can perfectly overlap each other. Same size, same shape, all the angles are the same. Alright, so on my picture, A, B, C, D, E is the pre-image in red, and then A prime, B prime, C prime, D prime, E prime is the image in blue. Notice this is just a translation right and up. I would figure out how much. So if you look at a picture, you're just like, how do I go from this left E right here to this right E right here? If you notice, I go right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I go right 10, then up 1, 2, 3. That should be the same for everything. I'll try C to C. Right 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up 1, 2, 3. Alright, that works for all the points. I could actually drag this across, and that should be true. For B, notice if I move this, that is right 10, up 3. If I use A, right 10, up 3. If I do for D, right 10, up 3. Alright, so that's the description in words. And actually, if you want to use a picture and try to find all the points, A is negative 7, 4. A prime is 3, 7, and so forth for all of them. Alright, so we have here a motion rule. So how does A right here turn into A prime? How does negative 7 turn into positive 3? How does negative 5 turn to positive 5? If you notice, we just add 10. That's what right 10 means. How does 4 turn to 7? You add 3. How does 6 turn into 9? You add 3. So the word description of the right 10 up 3 is what we use to figure out the motion rule. The motion rule is simply given a point in x comma y, the new point will be the original x plus 10 more, then the original y plus 3 more. So x plus 10 means right 10, y plus 3 means up 3. Alright, so the motion rule for translations follows common sense. If you have x plus some number, that means you go right, whatever that number is. If you have x minus some number, that means go left, whatever that number is. If you have y plus some number, that means go up. Y minus some number means go down. So here's some things you should be able to do. It says, given the motion rule, describe the effect in words. So given the original point x comma y, you're going to add 2 to the x, minus 3 from y. If you add 2 to x, that means you're going right 2. And then if you're doing y minus 3, you're going down 3. And this is a translation. Alright, if I try the next one, given the original point x, y, follow this formula, this motion rule. For x, you're going to subtract 100. That means left 100. And then for y, you don't change it. Y stays the same. You don't right say, you say y is unchanged. And this last one down here, given x, y, leave x alone, add 50 to y. That means we're just going to go up 50. Alright, and sometimes you can be lazy. Sometimes I'll just abbreviate. So like if I say right 2, down 3, you'll see me write R2, meaning right 2, D3, meaning down 3. Left 100 just means L100, and then up 50 just means up U50. Same thing. Alright, now to the reverse. Given the description, write the motion rule. Translate left 8, up 5. So left goes to x. So that's going to be given an original point. Our new point is left 8. That means you subtract 8 for x. And for y, you can go up 5, so you just add 5 to y. Alright, this next one, given a point, x, y, it says go right 3. So you're going to add 3 to x. And then for y, you're going to down 11. So you're going to subtract 11. And this last one, given our point xy, we're going to go up 77. X does not change. Leave x alone. But for y, add 77. All right, and what we can do with motion rules is this. You can literally just plug in the original point to find the new point. So if I had, say, C, if I added 10 to x, -3 plus 10 gives me 7. Then if I added 3 to y, 1 plus 3 gives me 4. So you don't have to use the picture to find everything. A lot of times they won't give you the picture. All right, so here's some more situations or scenarios. If G is at 1812, so point G is at 1812, and it's translated left 4 up 3, where's G prime? Left 4 means subtract 4 from x. And then up 3 means add 3 to y. So notice this is our xy right here. If I do 18 minus 4, that gives me 14. And if I do 2 plus 3, that gives me 5. Well, that is our coordinate for G prime. Our G prime is at 14, 5. Next one, if P prime is at -5, 14, and that came from P being translated down 1, right 5, where's P? Now we're going backwards. We have the end point, P prime the new point. So to undo this, so down 1, we'd undo it by going up 1. And right 5, you'd undo it by going left 5. So using this point, -5 and 14, we need to add 1 to go up 1. We have to subtract 5 to go left 5. So really our original point is -10, 15. That's where P, the original P, is located. Because now I go right 5, I add 5 to -10, that gives me -5. You go down 1, I subtract 1 from 15, it gives you 14. All right, if M is at that point, 3, -10. Find M prime using that. Well, hopefully you know this means right 20 and down 6. But we don't even need that right 20 down 6. So we just gotta use the formula, plug in. So our xy is right here. We're going to do 3 plus 20. Well, that's 23. Then we're going to do -10 minus 6. That is -16. We have our new x, our new y. That is M prime. All right, down here, if h is at 1, -4, translated to become h prime -2, 5, what's the motion rule? How does 1 turn into -2? You're subtracting 3. So given our original point, subtract 3 from x. Then how does -4 turn to 5? You're going up, you're adding 9. So y plus 9. There's our motion rule. All right, next. We're going to do reflections. We're going to talk about lines of symmetry. A line of symmetry or line of reflection are where we cut an image in half and both sides match perfectly or are mirror images of each other. So I have this arrow pointing up. There's only one line of symmetry. If I cut it right down the middle right here, and it's the same on both sides. If I cut it right here, and I could fold it in half right there. If I try to draw a sideways line, can I fold it right there? Would they match perfectly? No. If I move down here, would they match perfectly? Answer is no. All right, this next one, a rectangle, has two lines of symmetry. If I cut it directly sideways like this, I could fold it in half perfectly. I could also do it right here perfectly. But if I try this diagonal line, this will not work. Because I fold it over this, it's not going to match perfectly. So it only has two. Some people think it has more. An equilateral triangle has three. Hopefully you see just straight down through here. Or we could go this way. Or we could even go this way. And the last one is square. Square has four. You can go right down the middle, this way, sideways, diagonal either direction. You go this way, or I'll use black, this way. All right, anyways. Reflections are the flip. All right, reflections flip a picture over a line of symmetry. The size and shape stay the same, but the orientation may change. The pre-image and image are still congruent. So again here, A, B, C, D, E is the pre-image in red. A prime, B prime, C prime, D prime, E prime is the image in blue. Notice this is a transformation of a reflection over the x-axis, aka y equals 0. It's that green line. If we do the points, you get this. You know, A was at 3, 6. A prime is at 3, -6. B prime, B was at 3, 3. B prime is 3, -3. E was 5, 8. E prime is 5, -8. If you notice, all we do is keep the x's the same but change the y's to negative. So that's my motion rule. Given xy, leave x the same, multiply y by -1. It is only true for reflections of the x-axis. It's not true for any other reflection, so I don't actually like motion rules for reflections. In scripted words, just reflect over the x-axis. So the motion rule for reflections changes depending on the line of reflection. So you should not try to memorize the formulas, but learn the process. Here are the steps. First, draw the line of reflection. Then for each point, count horizontally or vertically to the line of reflection. Then finally count that same mirror away from the line of reflection. And if the line is slanted or diagonal, count to the line, turn, then count away from the line. So here's to reflect A, B, C, D, E over the y-axis, aka x equals 0. So here's my line of reflection, this upward line. Then for each point, I'm going to count 2 and away. So I look at A, to the line will be right 1, 2, 3. Then I go the same distance, 1, 2, 3. Here's my new A, that's my A prime. And actually, I'm not going to make it like that. So I'm going to do like this. Undo. Right, so for A, I go left 3, then left 3 more. Here's my A prime. For B, left 3 again. C goes left 1, 2, 3, 4, 5, 6, 7. Left 1, 2, 3, 4, 5, 6, 7. Here's C prime. D, left 7. E, left 1, 2, 3, 4, 5. Left 1, 2, 3, 4, 5. E prime, if I connect this, notice it's the same image. All right, we could try to find the motion rule, but again, that's not a good idea. It would actually be the same y value, but the x gets multiplied by -1. Let's try another one. Reflect this picture over the diagonal line y equals x. So hopefully I know that's mx is b, y-intercept is 0, then up 1 over 1 for the slope, or down 1, left 1, if you go that way. So this one's slanted. So I'm going to count from C, I'm going to the line, I'm going to go either right or down. I'm going to go right 2, but I have to turn, go down, down 2. All right, so that's my C prime. For D, I'm going to go right 1, 2, 3, 4, 5, then down 1, 2, 3, 4, 5. For B, right 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5, 6. A, I can go down if I want, so down to the line 1, 2, 3, 4, 5, 6, 7, 9, then right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So count one direction to the line, then turn, then do the other direction away from line. For E, right 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's E prime. If I connect it, it is a perfect reflection over the diagonal line. That's the mirror image. So it's kind of turned sideways now. If I fold over the diagonal line, they'll match perfectly. The rule here, I think, is just switching x and y. But again, you just label their points and see if you can find that yourself. Here's another one. Reflect this over the line y equals 3. So I draw my line y equals 3. Y is not allowed to change, constant. For A, I go down 1 again. Here's my new A prime. For B, up 1, 2, up 1, 2. That's my new B. For E, down 1, 2, 3, down 1, 2, 3. Here's E prime. C goes up 2, up 2. D goes down 1, down 1. All right, here's my picture. If you fold over that line of symmetry, it matches perfectly. Here's another one. Reflect over the line x equals 2. X equals the vertical line. X is only allowed to be 2, nothing else. You can count 2 and away. So for C, I go right 1, 2, 3, then again right 1, 2, 3. Here's C prime. B, 1, 2, 3, 4, 5, 6, 7 to the right. 7 to the right again. 1, 2, 3, 4, 5, 6, 7. A, right 7, right 7. D, right 1, 2, 3, right 1, 2, 3. E, right 1, 2, 3, 4, 5, right 1, 2, 3, 4, 5. Connect this. That's a perfect reflection over the line x equals 2. Last one. Here, graph y equals -2x plus 4. So y-intercept of 4. Then slope -2 down 2 over 1 down 2 over 1. Here's this. I'm going to reflect each point. For B, left 2 down 2. There's B prime. For A, left 1, 2, 3, 4 down 1, 2, 3, 4. Here's A prime. I actually don't have enough time for the last round, so we'll just end here. Thanks for watching. Ask questions, class. See you soon. Bye.